Welcome back, Phi-Sci family. This next presentation is introducing acceleration. Now that we've talked about speed and velocity, the idea of speeding up or slowing down is going to go directly into the idea of acceleration. So let's go. Acceleration is just going to be the rate of change of velocity. What does that mean? It really means how much your velocity is changing over a period of time. If you're speeding up, your velocity is increasing over a period of time. If you're slowing down, your velocity is decreasing over a period of time. So it makes sense then to actually find acceleration, that you're just going to take your final velocity minus your initial starting velocity and divide it by the total time elapsed. By doing so, you're going to get the actual acceleration of the object. Since it is going to be velocity on top and time on the bottom, it would end up being meters per second per second. And that's what the units are for acceleration. Or if you'd like to say it a different way, meters per second squared. Now, how can one accelerate? Well, we're just kind of scraping the surface with physics and physical science, but basically if you are speeding up or slowing down, you are accelerating. But since we're dealing with velocity, and we know the velocity is just like speed, but it has a direction, and technically there's more to it with something called displacement, but for our class, anyways, we know that it's speed with a direction. If you change your direction, you also change your speed, which means you then accelerates, or you have an acceleration. If you do both, you're accelerating. If you're speeding up, we tend to call that acceleration. If you're slowing down, we often tend to call that deceleration or decelerating. Think about when you were on your way to school this morning. Did you accelerate at all? Absolutely. If you were in your car, maybe at a red light, here's your car. As soon as the green light went on, you started driving and speeding up from 0. When you saw a red light, what did you do? You slowed down and stopped at the line in the street so that you didn't go into the middle. Why? You decelerated and slowed down because you didn't want to crash into oncoming traffic. Did you turn into the school? Maybe you were on 131st Street and you were turning into the school. Were you changing direction? Yes. Were you accelerating? Yes. When you graph a distance versus time when you're accelerating, you'll notice that it's a parabolic shape, a parabola, or half a smiley face. The reason for that is between every second, since you're getting faster and faster with acceleration, you are going to increase the distance you cover, which means that your line or your slope is going to get steeper and steeper. So it makes sense that in a distance versus time or a position versus time graph that you're going to slowly get higher and higher in that curve. And that's just because you're going faster and faster. Now, if you were to graph velocity versus time and you were accelerating, we know after every second your velocity is going to increase by a little bit. And that's why after every second it went from 10 meters per second to 20 meters to 30 meters per second to 40 meters per second to 50 meters per second. This is a nice constant acceleration. That's what happens when you accelerate. Your velocity increases as your time increases. If we wanted to find the acceleration of this race car here, and we started reading, we said the race car brakes and slows down from 28 meters per second to 13 meters per second. So that tells me that if I have 28 meters per second, that was my initial starting velocity because I slowed down to finally 13 meters per second, which would be my final velocity. It says that this happened in 3 seconds. If I write down 3 seconds, I know that seconds is a measurement of time. So now I have 3 variables that already have numbers. The question is, what is the acceleration? So that's what I'm looking for, acceleration. If we do the guess method here, these are all my givens. This is my unknown. Next would be my equation. And I know that acceleration is related by all of these variables that I have. Velocity final minus velocity initial divided by time. If I take that and start plugging in numbers, my final velocity is 13, my initial velocity is 28, and my final time, or my time here total, is 3. By doing so and doing the work a little further, I get negative 15 over 3. And if we bring it up to the top here, negative 15 divided by 3 ends up being negative 5. Now, since this is acceleration, it's in meters per second squared. A lot of people were confused in class. How could acceleration be negative? I thought, like speed, it had to be positive. Well, that's not true. Negative acceleration often means, at least in this level of physics, that you're decelerating or slowing down. And were you? Yeah, you went from 28 down to 13 meters per second. So by slowing down, you were decelerating, which means you get a negative acceleration. That's not always the case in higher level physics, but for now, that will do. What if we tried one more problem? You're at the starting line still, and you move and speed up. So if you're at the starting line, think about it. Are you moving? No. So your initial velocity is 0. But you speed up and you get an acceleration here of 3.5 meters per second squared. And it says that after 5 seconds is what you're looking at. So that's a time, 5 seconds. You want to know what the final velocity is for the race car. So that's the thing we don't have. So if you look, we have the givens, we have our unknown, just final velocity, but we know that there's an equation that ties all this together, and that's the acceleration equation. If I plug that in, 3.5 meters per second squared, my velocity final, I don't know, my initial velocity is 0, and my time is 5. Now this is just an algebraic equation that I can solve for. Let's bring that up to the top so we can keep working on it. 3.5. Velocity final minus 0 is going to just give me velocity final left over divided by 5. Now, what do I do to get rid of that 5 and velocity final by itself? I'm going to multiply by 5 to both sides. That's going to cancel out my 5, which is going to leave me with velocity final is equal to 5 times 3.5. Throw that in your calculator. 5 times 3.5 should be about 17.5 equals your final velocity. But you're not done. Don't forget your units. We know the velocity is like speed, which is meters per second. And there you have it. You solve for velocity final by just using a simple algebraic equation for acceleration. And since this object was speeding up, it makes sense that you went from a lower velocity of 0 to a higher velocity of 17.5. All right, so acceleration is definitely different than just speed or velocity, though it includes them in the thought process. Keep on thinking, keep on working, and thanks for listening.